negative on this one. And,
the negative and positive, huh?
Right.
Okay.
Okay, now
let's see.
Turn on this board and turn on this board. Now normally the 120 volts comes out of that inverter.
I see that,
with a battery up there.
Was that a real stat or something there? Or what?
Well, that actually is an auto transformer.
Transformer.
It takes 120 volts down to maybe 50 to run the big power supply. So I give him a little spin in there. Turn on.
There you go. There you go.
Right now it's hitting this. The CD is kind of wobbly.
That thing is, the CD is going in there.
Oh yeah.
Oh man, my video, I'm taking some video, man.
That's good.
Oh yeah.
Let me get into the way. You can go right up over the top and watch the rotor.
There you go, that's the rotor moving. That's it.
Now that's a pretty big mass that I'm spinning.
Now is that enough to generate electricity on the other side?
Oh yeah, you can take that. You can put a pulley on there and go into a generator.
What kind of torque does it have? Is it enough to...
Quite a bit, huh?
Quite a bit, huh?
It's pushing my hand pretty good.
That means it can charge battery.
Here's
the wheel spinning.
Yeah, the wheel has 12 neo magnets on each side.
It's getting hot.
Huh?
I can feel the heat, man.
Yeah, but that's from the storage. These things are actually doing all the work. And just feel them. They're not even hot at all. They're actually taking the battery into the motor coils.
See, there you go. And that's your CD thing, huh?
Yeah, it's kind of wobbly. I gotta make another one.
It must be the heat that causes it to wobble.
Well, it's mounted to a coupling.
You need to strengthen it. So there it is, Gary and his machine.
Yeah. So now the next step, what I did right here, I took away these chips and I ran a wire from here right over to here.
Ah,
And I bypassed the one shot. The one shot was putting out a square wave to each of these boards, and they drive these guys, and this controls, these are switches for these wires. That's all they do is switch. And well, the pulses were actually, this one was still on when this one turned on. That means the 12 volt batteries are shorted.
and what is the draw on the battery? How many amps is drawing?
There's, I think, 29 amps.
Wow,
29 amp pulses.
Pulses are not
No,
average.
they're very, very short. They're like 5 millisecond pulses.
So you wouldn't know until when your battery will run down. Then.
Well, it's down now, actually.
How quickly?
Oh, I've run it for probably 15 minutes, and it's
15
down to
minutes,
11.8 or 11.6 or something.
Oh, okay.
And then 12.3 on the other one. But,
11. Oh, that's pretty exhausted.
so what you do is these guys here, you actually, this is running the motor, this set, and this set right here, each of these coils down here, there's 2 coils in there. So one coil is made up of 2 coils, and one is a pickup coil, and that's right here. Now I can actually, there's the signals in there, I can take those and capture that energy at certain times without loading the motor. And then I store that energy in caps, these little capacitors here. And through these little bridge rectifiers, I got to build this circuit. And then I can actually, when the positive battery is running the motor, an impulse will occur and dump the cap into the negative battery. When the negative battery runs the motor, then the positive gets charged. So it bounces energy back and forth.
But eventually you run out, right? or do you
I'm
maintain?
not recharging yet.
Oh, okay.
But this system right here is going to replace the two batteries. Will be replaced by
Okay.
these blue capacitors.
I see. I see.
Now, this thing runs on one 12-volt battery through an inverter. 120 runs a 9,000 volt transformer. That runs a Tesla spark gap, and then there's a Tesla coil back there, and that gets rectified through these big rectifiers over here, and that goes into these two caps, and then these wires here go down to the two PC boards, and they actually monitor these caps, and there's a switch on the PC board that controls the energy stored in each of these. One's positive, one's negative, so that replaces the battery. And so one battery runs the whole thing on 48 watts.
And then you charge this one up again? Or no more. You're just using that one.
I won't even have the.
Yeah.
Well, one of those batteries will be here.
Right.
So energy from this will come back and keep this battery charged. So the whole system runs basically itself.
All right. Then you can put a propeller on that shaft.
Yeah. You can put, but you can see I've got no rotor out here and none out here.
Right.
And if I had two more rotors, then I would have twice as much power. And so I'm wasting a whole magnetic field on this side. It's not doing anything. But I can actually add coils right here to pick up even more energy to keep the batteries charged.
So if you miniaturize everything, then it's a nice package.
Well, I want to take this 18-inch rotor and make it thinner, same width, only have them be a whole, like 8 of them on one shaft, and be able to turn on the energy as I need it to power the car. So that's what we're going to do.
All right. Thank you, Gary.